Wind is my most drought-resilient crop. The wind blows even during a drought, even when I can't have livestock on the ranch. I don't know of a single landowner that has a wind farm that isn't grateful for it. I know that there's been thousands of jobs created that would not have been there otherwise. I've heard as high as 60,000 homes being serviced by this wind farm, basically because of the quality of the wind. It tends to blow here all the time. We've put power in the grid every day since this project was built. If you'll notice over there, those trees are actually leaning. They've never had a windless day in their lives. The grass and the wind are inexhaustible, and if treated properly, we can be doing this centuries from now.
When All in America visited Pete Farrell's ranch in Kansas this May, we were gobsmacked, not just by the power generated by the wind turbines on his land, by the sheer size of them. I mean, those are bison grazing on the ranch. And bison are big. They can grow over 6 feet tall, and they weigh a ton, and they are absolutely dwarfed by the wind turbines. It made us wonder, how on earth does something that big even get from a factory to a wind farm? So we traveled to North Dakota to find out.
I've had people ask me what these things are. Best result I ever came out with was that it was a prosthetic limb for a whale.
The sheer scale of these blades boggles the mind.
Each one of these blades, they weigh about 9 tons. The diameter is about 300 feet, so that's about the length of a football field.
And they are everywhere.
In the U.S., we have about 15,000 wind turbines.
GE got into the wind business in 2002. It now makes 40% of all wind turbines in the U.S. and is constantly refining its technology to safely harness the wind.
When you look at a wind turbine, that wind flow creates 2 forces. One is a torque. Torque turns the gearbox, which turns the generator, which puts the kilowatt hours onto the grid. It also creates a thrust, and the thrust that is being created is equivalent to 5 F-18 engines trying to pull the turbine over. We invest in a lot of technology to be able to develop new controls that allow you to operate the turbine in those conditions.
Those designs are made into reality at factories like LM Wind Power in Grand Forks, North Dakota. Business is good. The plant employs 630 workers and runs 7 days a week, and they expect to produce 1,800 blades this year alone.
About 6 blades are coming out, sometimes 5, are coming out every single day.
And every single one of these blades needs to be loaded and transported to its final destination, often thousands of miles away. It's a massive undertaking, literally.
A normal truck and trailer are 80 foot, and we're almost, at times we're almost 3 times longer than them.
This September, the final destination for 3 of those blades was just 255 miles away, a brand new community wind farm in South Dakota. A drive that normally takes 4 hours took almost twice that long, down the freeway, through small towns, until finally reaching Oak Tree Farm.
This is the first of the delivery of the 11 turbines that'll be here. It's kind of like Christmas morning, opening up all these big presents and big packages.
A 6th-generation family farm, Oak Tree is now branching out into wind.
We've been farming wheat and corn and soybeans, so we thought we'd give a chance to farm the wind.
When all 11 turbines are up and running, the wind farm is expected to power 5,000 homes.
Well, there's one thing you can count on in South Dakota is the wind.
Wind energy supports an estimated 50,000 jobs across the country and is now the fastest growing source of power in the United States.
The U.S. has about 5% electricity generation coming from wind power. Put that in perspective, the whole nuclear industry is about 12 to 15%, and they've been doing it since the 50s.
And who knows what the future growth trajectory for wind power could look like.
We're at a point where energy independence is what we've been looking for. We're virtually there.